Now we're going to talk about the determinants of price elasticity of demand. What characteristics make something elastic versus not very elastic? Okay, well, the first one is the number of substitutes. Well, you know what? There's a lot of substitutes for Baby Ruth candy bars. If they don't have Baby Ruth, I get a payday. All right. There's all kinds of stuff out there, all kinds of sweets. Okay, there's a zillion substitutes. So they would tend any particular candy bar or Twinkie or Zingers or whatever, because there are donuts, there's a lot of stuff out there. Okay, so any given donut or candy or whatever is going to have a lot of substitutes and thus high price elasticity. No one has any pricing power there. If the donut company rate doubles their price, believe me, people will find other sources of donuts. On the other extreme, emergency medical services has very few substitutes, if any. Okay. What's the substitute for heart surgery? Well, death. Death. Most people don't consider death to be a very good substitute. So emergency medical services or life-saving services would be extremely inelastic because there are no other substitutes. Time. The greater the length of time, the more elastic something it becomes, the greater horizon of time. For example, let's say gas prices doubled today while you're in class. They double. How many of you will still drive home? Well, everyone is still going to drive home. No one's going to say, oh my gosh, gas prices have gone up and I'm not driving anymore. I'm going to leave my car right here. I'm going to walk. I'm going to take the bus. I'm going to do whatever. But that's today. A week from now, chances are maybe you've been able to organize your schedule a little better, a little more efficiently, so you don't drive as much. A couple of weeks from now, maybe you've gotten together a carpool or maybe become familiar with the bus system. So as time goes on, you're able to find ways around this price increase. And a year from now, maybe you have a new job. Maybe you've got a job closer to home. Or you have even moved closer to your job. So as the time horizon lengthens, the more elastic, everything else the same, of course, everything remains constant. You've got a higher elasticity. Proportion of the budget. Well, we talked about that when we did the little graphical thing of on the demand curve, showing how as you move up the curve, the total revenues, how you can model that elasticity and total revenues. And yeah, using that same example just as a review, salt, when it's like 10 cents, can double in price and no one will notice. Okay, it's a tiny, tiny, tiny portion of your budget. But gasoline is a pretty big portion of our budget. So, yeah, that's going to be less elastic. More elastic, sorry. Everything else equal, it'll be more elastic. The bigger the portion of our budget, the more price sensitive we are. Everything else the same, everything else constant. Okay, gasoline, as we'll see, is a fairly inelastic good. But it would be even less elastic than it is if it was a lesser portion of our budget. Okay, so it's just more elastic because it's a greater portion of our budget than it would be otherwise. Otherwise, it'd be like salt. We wouldn't care if we, spilled gas all over the place. So what? It's 10 cents. 10 cents a gallon, right? Nobody really cares. Okay, so the bigger portion of your budget, the more elastic. The less the proportion, the less elastic. Is it a necessity or a luxury? Well, necessities tend to be fairly inelastic. Electricity, for example. Luxury, going out to eat in a restaurant, is a luxury, and that'd be fairly elastic. So if things got tight, okay, if you lost your job, let's say, what's going to go first, the electricity or the restaurant meals? It's pretty clear which one's going first. And, how broad the market? This is going to take a little explanation. How broad the market? Well, okay, there's the transportation market. We can look at a good just called transportation. That's as broad as possible, transportation. Or we can look at specific types of transportation, cars, airplanes, buses. Or we can look at specific brand names, let's say, of cars. GM, Ford, Chrysler. Okay. Now, the broader the market, the less elastic. Okay? The elasticity of travel is lower than the elasticity of travel in a Lincoln Continental. Okay? Why? Well, we go back to our substitutes. The more narrow the market, the more substitutes there are. Okay, so travel inelastic, yes. Travel by car and a specific car more elastic because there's a lot of other options. Okay, well, the last thing we're going to do with price elasticity of demand, then we're going to move on to, we've got income elasticity, cross price elasticity. Oh boy. Okay, so here's the thing we're going to have to deal with now. And that is the midpoint formula. Oh yeah, this is always such a joy. Well, in real life, nobody uses the midpoint formula. There's other ways of calculating elasticity, but for undergraduate students, I guess it's generally believed that they should do some number crunching and actually calculate this thing. So I always start out with students so they know what elasticity is and how it's used and that sort of thing. But now we're going to actually calculate it. We're going to do some number crunching. So, how do you calculate this thing? Using the midpoint formula. Well, here we are. Elasticity is percent change in quantity divided by the percent change in price. Well, let's review percent change. And what we're going to use here is just junior high mathematics, really, junior high arithmetic. So just a percent change. The general percent change formula is just x2 minus x1 divided by x1. That's just the most general, broad formula. And let's forget, there we go, times 100 to convert from a decimal to a percent. So let's suppose that a number goes from 10 to 11. What's the percent change between 10 to 11? Well, if we were starting out, x1 would be where we're starting out. okay? And x2 would be where we end up. So this x2 minus x1, that would be 11 minus 10. That's just the change. So this is just the change in the numbers. But then we divide that change by where we started, x1, okay? So it's the change as a proportion of the number we started with, and so that would be 10. So that's 1 over 10 equals 0.10. And if we want to convert that to a percent, we just multiply by 100. 100 times 0.10 equals 10%. Now, notice something else here. Let's say we're going the other way. In fact, let's draw a curve here. Let's say the price goes from, here it's going from 10, well, let's go on full guns. Let's say the price goes from 10 to 11. So we're going from this point to this point along the demand curve. Okay, so we just figured out the percent change in price when we're going from here to here. 10 to 11. Now, let's suppose we're going the other way, from this point to this point. If we're going from this point to this point, we're going to get a different number. Why? Because this time, P1, well, we used X1, X2, using our general formula for just percent change for anything. This x1 is now 11, where we're starting out here, and then we're going down to, we're starting out here, and then we're going down to here. Okay, so that would be, well, let's x2 minus x1 divided by x1, and so we've got x1 okay, that's 1, sorry. So that would be 11 minus 10, or 10, no, sorry, we're starting out at 11, we're ending up at 10. So that would be 10 minus 11. Now this is, ignoring the price, the sign change, we're fine. The actual change is the same, absolute value. 10 minus 11, 11 minus 10, the only difference is the sign. And with price elasticity of demand, we don't care about the sign, right? Because we always know it's going to be inversely related, so we drop the sign anyway. But here's where it's different. Divided by x1, but this time x1 is 11. Instead of 1/10, it's now 1/11. And now it's roughly negative 0.09. So ignore the sign, because we don't care about that with price elasticity of demand. Remember, we're just supposed to remember that it's an inverse relationship. But we do get a different number. Here we get 0.10. Here we get 0.09. That's a problem, okay? We don't like that in undergraduate principles of economics. So let's see how we're going to fix this. Well, first of all, okay, let's go back to more specifically economics. Elasticity, percent change in quantity divided by the percent change in price. How can we calculate the percent change in quantity? Well, that would be just Q2 minus Q1. See, I'm using just the Q's now, divided by Q1 times 100, right? And then percent change in price would be P2 minus P1 divided by P1 times 100. There we go. Here's the percent change. Here's the percent change in quantity. Here's the percent change in price. Well, there's a couple of adjustments we're going to make here. Now, the biggest adjustment is because the the standard approach to principles of economics is that we don't like that we get a different elasticity going from this point to this point, and we get another one from this point to this point. You know, they should be the same, right? From this point to this point should be the same elasticity coefficient for our purposes, whether we're going from here to here or here to here. All right, so we fix that by taking the average, or the midpoint. Okay, the midpoint. So how do we get the midpoint? So we're just adjusting this formula from what we're doing is making it 10 times more complicated than it ought to be. That's what we're doing. See, right here it'd be real simple. This is easy. And it's still easy. Just you know, kind of pay attention here. So instead of dividing by Q1, and if we go the other way, we'd be divided by the other number, Q2. We're going to take the average between Q1 and Q2. Ah, there we go, the midpoint. So how do we get an average? Well, we're going to Q2 plus Q1. To get an average, we add the numbers together and divide by 2, right? If we want any average of any two numbers, add them together and divide by 2, and that's what we're doing. We're going to add them together and divide by 2. And the same thing down here. Okay, so that's all we're doing. We fixed the formula. We fixed it, so we're going to get the same thing. So we divide by the average of the two, and now we don't get a different number when we go up the demand curve versus going down the demand curve. We're going to get the same absolute value, the same number. Okay, then we multiply by 100 here to convert from a percentage to a decimal to a percentage. But look at this. We're divided by 100. 100 divided by 100 is what? It's 1. It cancels out. So we don't need that anymore. And what else don't we need? These 2's cancel out. So what we're left with is Q2 plus Q1. Sorry. It's been a long day. Here we go. It's fresh and clean. Percent change in quantity, percent change in price equals Q2 minus Q1 divided by Q2 plus Q1. Divide that whole thing by P2 minus P1 divided by P2 plus P1. There you got it. There you got it. Easy peasy. Now, let's do this. Now, if you want, and this is only if you want, I think it's just fine like this. But if you want to take this part and invert it and multiply up here, you can. Okay, so that would be P2 plus P1 divided by P2 minus P1. So if you wanted to just do this and forget all that and just have this, that's fine. You know, pick your poison, whichever one. I think it's just fine to we can simplify it any way we want. But that's a formula you might see somewhere. So anyway, I just figure it's good enough to leave like this. That's I'm a simple guy here. Okay, so Let's do one. Okay, 5, let's say that's 20, and 7, let's say that's 18. Okay, here we go. The price, and it doesn't matter which direction you're going because we're taking the midpoint, so it doesn't matter, but let's just say that the price goes from 5 to 7, and that causes the quantity to go from 20 to 18. So since we're starting at 5, that is P1. This is P2. Let's see, P1. So if P1 is 5, Q1 is 20, and P2 is 7. So that means Q2 is 18. Okay, now we just plug. See, this is just mindless. I mean, there's no economics here. This is just pure math. The economics is in interpreting the number. What's important is that you know what the elasticity coefficient means. But again, they make way too big a deal out of this formula, actually, to calculate it. The calculation, the economics is not in the calculation. It's in the interpretation. Okay, I've whined about that enough. So let's punch in the numbers. Let's plug them in. Q2, 18. Q1, 20. Then 18 plus 20. Okay. Divide that whole thing by P2 minus P1. That's 7 minus 5. And divided by 7 plus 5. Okay, 18 minus 20, that's minus 2. Here, let's move it over here. 18 plus 20, that's 38. And over here, we've got 7 minus 5, it's 2. 7 plus 5, 12. Okay, now we can get fancy and invert and multiply and all that if we want. But I say just get out the calculator, and they're going to have some rounding errors, but it's not going to be serious. So minus 2 divided by 38. And I'm rounding it out. Well, I better go out 3 places. That is minus 0.053, and 2 divided by 12 is 0.167. And again, I'm making no effort to avoid rounding errors, and so it shouldn't be an issue. Whoops, 0.05. I still have to punch in the right numbers. 0.053 divided by 0.167 equals minus let's put it over here, minus 0.317. Okay, so there's our price elasticity of demand, 0.317. Now, let's interpret that. The important thing is to interpret it. Here's how you interpret it. Percent change of quantity divided by percent change of price equals 0.317. Remember, we don't care about the sign with price elasticity of demand. This is 1. So what that means is, after all that number crunching, it means a 1% change in price will result in a 0.317% change in quantity, the opposite direction. So if price goes up by 1%, quantity goes down by this much. If price goes down by 1%, quantity goes up by this much. That is inelastic. That's it. That is it. All right, that's enough of the midpoint formula.